Hey, so today we're gonna we're gonna do a reaction video to Andrew Ng's latest, maybe not the latest, he's pretty prolific, but he was presenting about 2 weeks ago to Sequoia Capital, who's a big VC firm. Anyway, it's great because it talks about the agentic workflows that he's studying. So this is state of the art, and it plays into the patterns that I was mentioning in my previous video, where we took we had ChatGTP make a prompt for Suno, and then we took the words from Suno and put them back into ChatGTP to make a different cover art. But he talks about that in this theory I'm calling the AI organization, AI organizational theory. So let's take a look at it, and I'll pause and add color commentary from time to time, but I think it's fantastic. I watched it earlier. So without further ado, let's get going.
All of you know Andrew Ng as a famous computer science professor at Stanford, was really early on in the development of neural networks with GPUs. Of course, a creator of Coursera and popular courses like deeplearning.ai. Also,
he's been doing this for a really long time, really well respected. He's taught at Stanford, but he's also kind of world famous known. Amazon today just announced that Mr. Ng's now on Amazon board because of his expertise in AI, and presumably because he probably just knows everybody in the AI space. So over my career, what I've noticed is, like, listening to these kinds of people, they tend to summarize the pulse of the community, and he might have some clues for you as to where things are going. So that's why we're bringing this in. Again, this is kind of state of the art. Andrew Ng is world class. So, let's study the people that are world class to see where things are right now, because that's where we're going. Okay. So, yeah.
Also the founder and creator and early lead of Google Brain. But one thing I've always wanted to ask you before I hand it over, Andrew, while you're on stage, is a question I think would be relevant to the whole audience. 10 years ago, on problem set number 2 of CS229, you gave me a B. And I was wondering, I looked it over, I was wondering what you saw that I did incorrectly. So anyway, Andrew.
Thank you, Hansin. I'm looking forward to sharing with all of you what I'm seeing with AI agents, which I think is an exciting trend that I think everyone building in AI should pay attention to. And then also excited about all the other what's next presentations. So AI agents, today the way most of us use large language models is like this, with a non-agentic workflow where you type a prompt and generates an answer. And that's a bit like if you ask a person to write an essay on a topic, and I say, please sit down at the keyboard and just type the essay from start to finish without ever using backspace. And despite how hard this is, LLMs do it remarkably well. In contrast, with an agentic workflow, this is what it may look like. Have an AI, have an LLM, say, write an essay outline. Do you need to do any web research? If so, let's do that. Then write a first draft, and then read your own first draft and think about what parts need revision, and then revise your draft, and you go on and on. And so this workflow is much more iterative, where you may have the LM do some thinking, and then revise this article, and then do some more thinking, and iterate this through a number of times. And what not many people appreciate is this delivers remarkably.
Okay, so love this. Notice that you could just give the GTP, how most of us use it, the GPT, you can just give it a prompt and expect an answer. But how most of us think, in fact, how we problem solve when we're really doing something hard, we tend to do this sort of, I always coach this sort of thinking. Okay, what's the high level flow of steps if we were to break this thing down? Okay, in doing step 1, what do we need to do? Okay, let's do it. Did we do it well? It's the same kind of thing you teach when you're teaching your kids to do homework. And maybe that has something to do with more about the nature of problems and problem solving than it does about LLMs, because this is the kind of thing we've been doing in computer science for forever. Chunking problems, breaking them down, solving them. That's why we have functions or methods. But I think it's interesting to think about, like, well, we could do this meta problem solving and have agents kind of work together to solve each small chunk. Anyway, just wanted to interrupt to kind of connect the dots. When we're talking about agentic workflow, we're talking about breaking things up and then solving each piece of the puzzle with a higher quality.
Better results. I've actually been really surprised myself working these agent workflows, how well they were. I want to do one case study. My team analyzed some data using a coding benchmark called the Human Eval benchmark, released by OpenAI a few years ago. But this says coding problems like, given a non-empty list of integers, return the sum of all the odd elements or uneven positions. And it turns out the answer is a code snippet like that. So today, a lot of us will use zero-shot prompting, meaning we tell the AI, write the code and have it run on the first pass. Like, who codes like that? No human codes like that. We just type out the code and run it. Maybe you do. I can't.
I've met a few people who do, but ultimately in their head, they're just doing this and holding all that data in their head and then putting it into the computer. So they're using like their memory as a scratch pad. But still, right, so if we let the computer, like we prompt it, and maybe future models will have this kind of high-level reasoning built in. But even with humans, we end up having to teach this problem-solving technique. Right around third grade, I think, is at least when I've got to start teaching my kids this kind of reasoning, how to break complex problems down. And then it doesn't ever stop. Most of the coaching that I do is this kind of algorithm. So it's no surprise to me that this helps LLMs or any kind of AI do its job better.
I'll do that. So it turns out that if you use GPT 3.5, zero-shot prompting, it gets it 48% right. GPT-4, way better, 67% right. But if you take an agentic workflow and wrap it around GPT 3.5, say, it actually does better than even GPT-4. And if you were to wrap this type of workflow around GPT-4, it also does very well.
That's really powerful and interesting, because running a GPT-3 process is much cheaper than a GPT-4 process. So if you can get the same results with a cheaper, because it costs less to run because it's less compute, a cheaper model, there's real economic value in that. And he touches on that, I think, later in the video. But it's interesting to see how following a new pattern can really get you, 20%? Yeah, about 20%, 30% better performance. So this is something we're going to have to pay attention to.
And you notice that GPT 3.5 with an agentic workflow actually outperforms GPT-4. And I think this has, and this means that this has significant consequences for, I think, how we all approach building applications. So agents is a term that's been tossed around a lot. There's a lot of consultant reports talk about agents, the future of AI, blah, blah, blah. I want to be a bit concrete and share with you the broad design patterns I'm seeing in agents. It's a very messy, chaotic space. Tons of research, tons of open source. There's a lot going on, but I try to categorize a bit more concretely what's going on in agents.
There is a lot going on in this space. And it doesn't take much research to figure that out, but there's really a lot going on, and things will stabilize over the coming months as true winners start to emerge in all these different battle of ideas. I love it. We're in the time of revolution. There's lots of chaos. But he's going to kind of outline the four major patterns. I'm really thankful for this because it is chaotic, and it's hard to kind of even categorize when you're reading a new paper on where it fits in. So I really love how he's categorized this, given his breadth of pattern matching that he's had over his decades of experience in this space. So these are very powerful patterns to look for.
Reflection is a tool that I think many of us should just use. It just works. To use, I think it's more widely appreciated, but it actually works pretty well. I think of these as pretty robust technologies.
He'll get into this, but these are the older parts of, since generative AI, we've seen these working. Those were kind of intuitive from the beginning. So no wonder we have a better handle on them.
Use them, I can, almost always get them to work well. Planning and multi-agent collaboration, I think it was more emerging. When I use them, sometimes my mind is blown for how well they work. But at least at this moment in time, I don't feel like I can always get them to work reliably. So let me walk through these 4 design patterns in a few slides. And if some of you go back and yourself will ask your engineers to use these, I think you get a productivity boost.
So I think Suno probably uses planning as a pattern, and it does fail sometimes, and then it'll retry, or it'll ask you to hit retry. So he's right, they're not 100% yet, but I think we'll get better at it as we go.
Quite quickly. So reflection, here's an example. Let's say I ask a system, please write code for me for a given task. Then we have a coder agent, just an LLM that you prompt to write code to say, def do task, write a function like that. An example of self-reflection would be if you then prompt the LLM with something like this. Here's code intended for a task, and just give it back the exact same code that you just generated. And then say, check the code carefully for correctness, sound efficiency, good construction criticism. Just write a prompt like that. It turns out the same LLM that you prompted to write the code may be able to spot problems like this, bug in line 5, and fix it by blah, blah, blah. And if you now take his own feedback and give it to it and re-prompt it, it may come up with a version 2 of the code that could well work better than the first version. Not guaranteed, but
that doesn't surprise me because the human brain kind of works. And I feel like I know the machine LLMs are different from the human brain, but there's also a lot of parallels in pattern matching. But if you have a developer, you have them write code in the morning, then they go for a walk, have a snack, come back and look at their code again, they can usually find bugs easier. And it has to do with just context of the problem and the way your pattern matching works in your brain so that it can find new things. And you can do this with LLMs. I've been doing it to make things better, saying, are you sure this is true? Or can we validate that? Or those kinds of things. And it's really a powerful thing.
It works, often enough for this to be worth trying for a lot of applications. To foreshadow tool use, if you let it run unit tests, if it fails a unit test, then why did you fail the unit test? Have that conversation. Maybe to figure out, fail the unit test, so you should try changing something and come up with V3. By the way, for those of you that want to learn more about these technologies, I'm very excited about them. For each of the 4 sections, I have a little recommended reading section at the bottom.
I might do a video on each one of those recommended readings. Again, he's doing the filtering for us. He's probably read 10 to 20 times the papers that that you and I have on AI. And he's pointed out the best ones. This is goldmine, people.
Bottom that, hopefully gives more references. And again, just to foreshadow multi-agent systems, I've described as a single coder agent that you prompt to have it, have this conversation with itself. One natural evolution of this idea is instead of a single coder agent, you can have 2 agents, where one is a coder agent and the second is a critic agent. Mm-hmm. And these could be the same base LM model, but that you prompt in different ways. We say one, you're expert coder, write code. The other one say you're expert code reviewer, so review this code. And this type of workflow is actually pretty easy to implement. I think it's such a very general purpose technology for a lot of workflows. This would give you a significant boost in the performance of LMs. The second design pattern is tool use. Many of you will already have seen, LLM-based systems using tools. On the left is a screenshot from Copilot. On the right is something that I kind of extracted from GPT-4. But, LLMs today, if you ask it what's the best coffee maker, in your web search for some problems, LLMs will generate code and run code. And it turns out that there are a lot of different tools that many different people are using for analysis, for gathering information, for taking action, for personal productivity. It turns out a lot of the early work on tool use turned out to be in the computer vision community, because before large language models, LLMs, they couldn't do anything with images. So the only option was that the LLM generate a function call that could manipulate an image, like.
So this is tool use is an interesting word because it is more generic, but it's the idea of using essentially APIs. So have your LLM know it's not good at something, but know that something else is, and then have that have the one call the other and say, here, you're better at this task than I am. Do it and give me the results. And that's also a problem we see in computer science all over the place. And that's why we have APIs for everything. So this is just the same thing, new again with AI. And this is a tried and true pattern. So it's no wonder that it's working.
Generate an image or do object detection or whatever. So if you actually look at literature, it's been interesting how much of the work in 2 years seems like it originated from vision, because LLMs were blind to images before, GPT-4V and Lava and so on. So that's 2 years, and it expands what an LLM can do. And then planning, for those of you that have not yet played a lot with planning algorithms, I feel like a lot of people talk about the ChatGPT moment where you're, wow, never seen anything like this. I think if you've not used planning algorithms, many people will have a kind of a AI agent. Wow, I couldn't imagine an AI agent doing this. I've run live demos where something fit.
Hopefully you had that feeling when you watched the dubbing video or the voice cloning video or the Suno video, and there'll be more down the line. But that feeling of wow, and those were probably all using planning underneath. That's why I'm calling them out. So take a look at how this works and see if it makes sense for you.
Failed, and the AI agent rerouted around the failure. So I've actually had quite a few of those moments like, wow, can't believe my AI system just did that autonomously. But one example that I adapted from a Hugging GPT paper, you say, please generate an image where a girl is reading a book, and it poses the same as a boy in the image, example.jpg, and please describe the new image with your voice. So give an example like this. Today with AI agents, you can kind of decide, first thing I need to do is determine the pose of the boy, then find the right model, maybe on Hugging Face, to extract the pose. Then next,
for those who don't know, Hugging Face is just this great website that it's almost like GitHub for AI, where you can get models of all different things, any open source models. Everybody has kind of agreed to put stuff there. So it's just a good community to go check out.
You need to find a post-image model to synthesize a picture of a girl as following the instructions, then use image to text, and then finally use text to speech. And today we actually have agents that, I don't want to say they work reliably, they're kind of finicky, they don't always work, but when it works, it's actually pretty amazing. But with agentic loops, sometimes you can recover from earlier failures as well.
And I think that's going to be key for those kinds of things is some form of judgment of quality at each step, kind of like the Andrew Carnegie thing that we're talking about, what comes in, what comes out, and then being able to measure that that's good coming out. That's going to be key for these kinds of algorithms, because everything else kind of stems from that. And you don't want to play the telephone game where you put something in and something unrecognizable comes out the other end. So you've got to maintain quality at each step of the system here. But if you do, you can do remarkable things like modify a pose or modify a picture, a character in an image, and then text to speech it out. Really crazy things.
I find myself already using research agents for some of my work where I'll want a piece of research, but I don't feel like, Googling myself and spend a long time. I should send to the research agent, come back in a few minutes and see what it's come up with. And it sometimes works, sometimes doesn't, right? But that's already a part of my personal workflow. The final design pattern, MultiAsian Collaboration. This is one of those funny things, but it works much better than you might think. But on the left is a screenshot from a paper called ChatDev, which is completely open, which is actually open source. Many of you saw the flashy social media announcements of a Devin. ChatDev is actually open source. It runs on my laptop, and what ChatDev does is an example of a multi-agent system where you prompt one LLM to sometimes act like the CEO of a software engineering company, sometimes act like a designer, sometimes act like a product manager, sometimes.
Yeah, so there's the whole science of organizational design and with people. Now we're going to get into, in the next couple of years, organizational design with AI and agents and tools. So you can start thinking of yourself as the CEO of a company, because you have a limitless amount of agents at your disposal, and we all have this superpower now. And it's at the very early days, and he gets into it. But this idea of AI organization is going to be a big thing in the next few years.
Exactly a tester. And this flock of agents that you build by prompting an LM to tell them, you're now a CEO, you're now a software engineer. They collaborate, have an extended conversation, so that if you tell it, please develop a game, develop a Go Monkey game, they will actually spend, a few minutes writing code, testing it, iterating, and then generate a surprisingly complex programs. Doesn't always work. I've used it. Sometimes it doesn't work. Sometimes it's amazing.
Again, quality is going to be something we're going to have to get AIs good at measuring, so that, because one of the biggest things that a CEO provides is taste. So purpose, creativity, mastery, and purpose, right? But the mastery in the taste and being able to kind of, set the vision for whatever the company is building, and being able to measure that, set the organization up so that everyone in the organization can measure the quality of the people that report to them. And this idea of work output quality is going to be a huge thing for improving these kinds of solutions. And I don't have the answer yet, but if you do, or you're interested in that, I'm sure there's a number of companies and scientists that would love to brainstorm. So anyway, keep going.
This technology is really getting better. And just one of the design patterns, it turns out that multi-agent debate, where you have different agents, for example, it could be have ChatGPT and Gemini debate each other. That actually results in a better performance as well. So getting multiple simulated AI agents work together has more power.
Is that new? No, we've known that for a while. That's why having a diverse team is great, because you have different perspectives and different patterns that you match on, so that you can come up with better solutions. So if you've got a chat GPT that's trained on one set of data, and the Anthropic Claude trained on another set of data, and they discuss something, they will bounce ideas off each other. We've known since biblical times the term iron sharpens iron. So what's old is new again.
Awful design pattern as well. So just to summarize, I think these are the patterns I've seen, and I think that if we were to use these patterns, in our work, a lot of us can get a productivity boost quite quickly.
You might want to take a screenshot of these papers and Google them. Just saying, it's pretty high value information right here.
And I think that agentic reasoning design patterns are going to be important. This is my last slide. I expect that the set of tasks AI could do will expand dramatically this year because of agentic workflows. And one thing that's actually difficult for people to get used to is when we prompt an LM, we want a response right away. In fact, a decade ago, when I was having discussions at Google on we call it a big box search, we type in a long prompt. One of the reasons I failed to push successfully for that was because when you do a web search, you want a response back in half a second, right? That's just human nature. We like that instant feedback. But for a lot of the agent workflows, I think we need to learn to dedicate a task in AI agent and patiently wait minutes, maybe even hours for a response. But just like I've seen a lot of novice managers delegate something to someone and they check in 5 minutes later, right? And that's not productive. I think we need to, it's really difficult. We need to do that with some of our AI agents as well. I heard some loss. And then one other important trend, fast token generation is important because with these agentic workflows, we're iterating over and over. So the LM is generating tokens for the LM to read. So being able to generate tokens way faster than any human to read is fantastic. And I think that generating more tokens really quickly from even a slightly lower quality LM might give good results compared to slower tokens from a better LM. Maybe it's a little bit controversial.
So that's referencing the thing in the first slide. So GPT-4, slower, more tokens, costs more, but is more accurate. GPT 3.5, faster, cheaper, but is using agents, might be what you want to use, so that you can do things cheaper and faster, at least for the coming months.
Controversial because it may let you go around this loop a lot more times. It's kind of like the results I showed with GPT-3 and an agent architecture on the first slide. And candidly, I'm really looking forward to Claude 5 and Claude 4 and GPT-5 and Gemini 2.0 and all these other wonderful models that many people are building. And part of me feels like if you're looking forward to running your thing on GPT-5 zero shot, you know, you may be able to get closer to that level of performance on some applications than you might think with agentic reasoning, but on an earlier model. I think this is an important trend, and honestly, the path to AGI feels like a journey rather than a destination. But I think this type of agent workflows could help us take a small step forward on this very long journey. Thank you.
All right, so there you go. Let me go back to that last bit there. He's saying this is a big step, so we need to pay attention to it. And I agree, and that's kind of why the inflection point I was talking about. Because let's face it, GPT 5 has been out, or 3.5 has been out for a while now, and I haven't started this channel until now. And it's because I'm learning more and more about, it's not just the chat, it's having a team of chats, having an army of chats. Maybe an army is not the word I want to use, like a whole company of information finders and solvers and problem solvers at your disposal. It's a whole new level of problem-solving power that we just haven't had. And it's going to shake things up in ways that's just going to change a lot. So for more like this, we're going to keep keeping our pulse on the cutting edge. And then we're also doing things to get you from beginner all the way to world-class, to get you in the room when, you know, so that we can all influence this technology and the future of this technology. So join the school that's getting up and going, and keep, like and subscribe to this, and stay in touch. Thanks.